So what you just wrote down are the rotation coordinate rules. This lesson's all about rotation, so turning shapes. So I will show you how to do it visually, but then the rotation rules are also really helpful when figuring it out with the coordinates. So yeah, we'll be using this as well, and now you have it written down. I also have it on the board too as a reference. This won't be up though for any test or like the EOCs or anything like that. For most of them, you can figure them out. However, the rotation rules, it is really helpful to have them memorized. So I have a note that you have to memorize this, but I have like a shortened version. So this is like the whole chart and how it works. And then if you're just trying to memorize the different rules, I would just memorize this. So you can take a picture of this like at the end of class if needed. But yeah, memorize these. Okay, so the whole idea is building concepts, of course, as usual. Rotation, spin a shape about a center of rotation. So center of rotation. And I'll explain what that means in a second. So rotation is just turning shapes. A figure can be rotated clockwise or counterclockwise. Clockwise or counterclockwise. And it shows it here. So clockwise would be the way like a clock hand moves. So it'd be this way. So, and clockwise is a negative rotation. So make a note, it's a negative rotation if it's clockwise. So all the way around would be negative 360 degrees. And then counterclockwise is this way, it's the opposite way that a clock moves, and that is a positive rotation. Positive rotation. So this all the way around would be positive 360 degree turn. But essentially negative 360 degrees, positive 360, it lands in the same spot. Okay, so center of rotation would be like this point right here. We're going to rotate this shape around the center of rotation. So this here is going to be the center of rotation in our little example. And all the points on the image must be equidistant from the center of rotation as the points on the pre-image. So as we rotate this shape around the center of rotation, all of these points have to be equidistant from the center of rotation as we rotate it. Okay, so if we're going to do a positive 90-degree rotation, it would be like a 90-degree turn here, so positive 90 degrees. And so we can actually draw a line to corresponding point. So let's use this as our corresponding point. This distance right here would be the same distance in this direction after the 90-degree rotation. So then this corresponds with this, and then we draw the shape like this. So all the points are equidistant from that center of rotation. And then these two lengths are the same, and then a 90-degree turn would make a 90-degree angle right here. Okay, and then a negative 90-degree rotation would go this way, negative 90 degrees. And then the shape would be down here. Again, 90-degree angle here. This length is the same as this, and then you would draw the shape. Okay, so just continuing to build the concept of a rotation down here. We're not going to fill out this chart, but we are going to rotate this shape. So here, this L, we're going to rotate it. First, we're going to rotate it 90 degrees. So 90 degrees would be one turn this way. 90 degrees, and then the shape would land right here. So this is at 3 and 5 here, so I'm putting it 3 and 5 here, and then it would look like this. So this is the shape after a 90-degree rotation. Some of your brains will do this easier than others. It depends on like your own spatial reasoning and all that, and everybody's brain is built a little bit different. So just be patient with yourself. So for this 90-degree rotation, what's happening is it's rotating about the origin. The origin is the center of rotation here, and you can take a corresponding point like this point D and point D prime right here, and draw a line to the center of rotation, which is the origin. And if it's a 90-degree rotation, it should make a 90-degree angle. It does. And then positive 90 degrees is the same as negative 270 degrees, around this way. Okay, so next we're going to do 180-degree rotation. So if this is rotated 180 degrees, it would land over here. Okay, and then this would be at 3 and 5 here, and it's like in this orientation. Like I said, some of your brains will do this easily, some of yours won't. It's okay. And then if we drew a line through the origin, like point here, this distance here should be the same distance to the corresponding point. And for a 180-degree rotation, it should make a 180-degree angle. And then 270 would land right over here. Again, I'm making my unit between 3 and 5, now negative 3 and negative 5. And this right here. Again, draw a line to the corresponding point. This is 270-degree rotation. So like 3 turns. And again, 270-degree angle and same distance from the center of rotation. And then positive 270 is the same as negative 90-degree rotation. So there's 90-degree angle here too. Okay, and then once you have that, we're going to flip to the next page. Okay, so on the back here, just continuing to build the concepts. Here, it wants us to rotate this shape 90 degrees counterclockwise. So that would be a positive 90-degree rotation, or that's the same as a negative 270-degree rotation clockwise. So it's one turn this way. So when you rotate that 90 degrees, it lands right here. That would be a positive 90-degree rotation. And also, if you were to take a corresponding point like this corner and this corner, and then draw a line to the origin, the center of rotation, it should make a 90-degree angle. And then the 90-degree rotation is the same as negative 270, so 3 turns this way. I said some of you will be able to do this in your mind easier than others. That's where the coordinate rules come in handy, because you can always use the coordinates to figure it out too. So if you're second guessing yourself, we can use the coordinate rules. So for a 90-degree rotation, the coordinate rule is xy becomes negative yx. And you can use the coordinates to figure it out. And for the next one, 180 degrees counterclockwise or negative 180 degrees clockwise would be 2 turns here. So putting it in this quadrant, and then drawing the shape, it would look like this. And that would be 180-degree rotation. And you can also use the center of rotation in a corresponding point to see it as well. So if I draw a line here and then to the corresponding point, it should make a 180-degree angle, which it does. And then positive 180 is the same as negative 180 this way. And the coordinate rule for 180 degrees is xy becomes negative x, negative y. And then for 270 degrees counterclockwise, which is the same as negative 90 clockwise, that would be 3 turns, so it puts it over in this quadrant. And it would look like this. That's 270 degrees or negative 90 degrees. And again, if you choose a corresponding point like this and this, it should make the angle to the origin. So 270 or 90 this way. And then the coordinate rule for this is xy becomes y negative x. And we'll practice the coordinates in a couple examples too. Okay, so remember counterclockwise when rotating positive degrees, and then rotate clockwise when rotating negative degrees. Okay, now we're going to practice rotating shapes. So it says rotate the figure 90 degrees counterclockwise. So it gives us the original figure. 90 degrees would put it over in this quadrant, but exactly where those points lie, my brain can't brain like that. Maybe yours can. But we can use the coordinate rules to figure it out. So for 90 degrees rotation, x, y becomes negative y, x. See? Yeah, just take your time with it. Yeah, your brain has to like kind of sort it all out because it's yeah. Anyways, okay, so I'm going to take the original points J, K, and L here. J, K, and L. J is at 1, 2, -4, -5. K is at -3, -1. And L is at -1, -4. And then I'll use the coordinate rules to find J prime, K prime, and L prime. Okay, so the coordinate rule, and again, take your time, is negative yx. So you take that y here, and you make it the opposite sign and put it here, and then just put your x in this position. And don't overthink it. Okay, so for k, again, negative yx, so I'm just going to put the y opposite sign right here, and then x goes here. Okay, and then negative y, so 4, and then x goes here. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4. J prime. K prime is at 1, -3. It's landing in the right quadrant too, so I know I did something right. And then L, 4, 1, 2, 3, 4, -1, L prime. And then here is our rotated shape. Okay, and then the next one, rotate the figure 180 degrees. So we're taking this figure, rotating it 180, so it's going to land in this quadrant over here. So 180 degree rotation, x, y becomes negative x, negative y. This one's the easiest one, which is cool, like coordinate wise. And then I'm going to take all my coordinates, L, M, N, and O. L is at 1, 3. M is at 3, 3. N is at 4, 0. And O is at 2, 0. And then from here, I'm just going to use the coordinate rule. So negative x, negative y. So it's just opposite sign. -3, -3, -4. 0 doesn't become negative, it just stays. And then -2, 0. And then I just graph. So I got L prime, M prime, M prime, and O prime. And then connect my dots. Okay, for the next one, we have triangle ABC, 270-degree rotation. They give us the coordinates for A, B, and C, but they don't graph it, so we'll go ahead and graph it. So A is at -3, 5, A. B is at 0, 2. And then C is at -5, 1. The dots, and there is our triangle. Okay, so a 270-degree rotation would be 3 turns, putting it over in this quadrant. What we can do is use the coordinate rule. So for 270 degrees, x, y becomes y negative x. And then I'm just going to take these coordinates and find a prime, b prime, and c prime. So for the y goes here, and then opposite sign for x. For b, the y goes here, opposite sign for x, but 0 doesn't have a negative. And then for c, y goes here, and then opposite sign for x. And then I graph it. It's landing in the right coordinate, which is a good sign. And 1, 5. And yeah. Then you could always check it as well. So if you choose a corresponding point like A and A prime, and you draw a line to the origin from both, it should be the same distance. Whoa. Same distance, and make that angle. So this is 270 degrees or 90 degrees here. Okay, and then the last two are just like practice problems. It says if point 52 is rotated counterclockwise 90 degrees about the origin, its image will be point what? Well, 90 degrees counterclockwise, xy becomes negative y x. So if we have 5, 2, that would become -2, 5. And that is our answer. And then for this one, how does a spinner appear after 270 degrees counterclockwise rotation about point P? Okay, well, 90 degrees would put it here. Then 180 would put it here. And then 270 would put it here. So it's this, which is this one. And there's one more that shows up on the homework I want to make you aware of. It's pretty easy though. So one thing that comes up on the homework is magnitude of rotation. So what magnitude of rotation is how far you have to rotate a shape for it to land on itself. So for example, if I have a regular pentagon, like all the sides are equal, all the angles are equal, what degree do I have to rotate it for it to land on itself again? So what you can do is just take 360 degrees and divide it by, in a case of a pentagon, 5, and then every 72 degrees, this would rotate onto itself. Or like if you have a square, I think this is one of the problems on there. If you have a square, all the sides the same and everything, 360 degrees divided by 4 would give you 90 degrees. So every 90 degrees, that square would rotate onto itself. Okay, that's all. So your to-do list is the homework. Once you're done with that, you can finish your Alex. If you're all done with the homework and all your Alex, let me know, and you can get your phone and chill and vibe. Okay, good job today. I know I pushed you for a Friday. That's awesome.